Let's have a look at links. I have just explained the difference between hard links and symbolic links. Now let's have a look at the command line, how exactly this difference behaves. So in order to do my demo, I'm going to show you ls-il on etc hosts. The file etc hosts is going to be the starting point of this demo. Now ls-l gives you a long listing. -i gives you the inode. The inode contains the unique administration of the file. First, let's create a hard link. In a hard link, you just type ln followed by the source file, which is the original file that you want to link to, and then the destination file. In this case is computers. Now if I'm doing ls-il etc hosts and computers to see the properties of both, then you can see that it's marked in blue, which is a bash way of indicating that it's a link. You can see the link counter that is set to 2, and you can see the inode that is exactly the same for both files. As I explained earlier, a hard link is just like a secondary name that you add to the same file. So there is no difference between the original file and the link that you've created. Now let's do a symbolic link as well. In order to do that, you do ln-s source file destination file. Now let's first have a look at ls-il again, where we can see how these files are all different. Now what you can see is that computers and etc hosts haven't changed at all, but you can see that new computers points to the computers file. It has gotten a new inode and permissions are wide open. And why are permissions wide open? Well, that is because permissions are managed on the destination file and not on this file. Now let's try something else and remove the computers file. If we do ls-il again, if we do ls-il again, now on the 2 remaining files, then you can see that there's a problem with new computers. It has turned black with red letters. And if you try to see the contents of new computers, which as an entry in the current directory still exists, well, we still get a no such file or directory. That is because the computers file doesn't exist anymore. Now, now let's try something else. In order to do that, I want to be a normal user. And this normal user is going to link etc shadow to my data. And what happens here? Well, this is a very nice new feature in RHEL 7. The normal user gets a failed to create hard link. Not because etc shadow doesn't exist, but because the normal user doesn't have any permission whatsoever on etc shadow. As you can see, no one has permissions on etc shadow, and that is because the hashed passwords are stored in the etc shadow file. This is a new security feature in RHEL 7. You can only link to files to which you have at least read permissions.